Okay, hello everyone to this engineering course on Introduction to Artificial Intelligence, Machine Learning, and Deep Learning. As we all know that these are very popular technologies or keywords in general globally because they are making their impact on societies globally in general and approach currently utilized and a global agreement to make sure that proper regulations are in place to assure the ethical, humanity enriching, serving attitudes when adopting these technologies in making products or further progress in these areas of research. Okay, so anyone interested, as if anyone of you have taken our prior courses, so we highly encourage students to pay attention to the keywords, like in this one, artificial, machine, deep learning in general. Anyone interested in knowing the history of these keywords, it's highly recommended to visit Britannica and find out the details, because it's in a topic in itself and a very interesting topic. But since our main focus is basically on discussing and introducing AI, ML, and DL, so we are not going to discuss that in our lectures. But you are encouraged. Anyone interested in knowing the details, please visit Britannica or any other similar reliable quality source in finding out the details. Okay, let's move on to the next slide. So we deliver all of our courses under Contact Field Institute, which is an affiliated company with Soft Galaxy Technologies Inc. We have a LinkedIn profile. Anyone interested in knowing the details, what we have done and what we do, please visit or connect with us on LinkedIn using this link. One of the key things that we believe in, that there is no shortcut to glory. It means you have to work hard, you have to learn the basics, and be clear on the basics if you want to progress in any field of your choice. Okay, so that's kind of a motto in delivering these courses or knowledge in general to the public. Okay, the emails are not mentioned here. I forgot to put in here, but anyone interested in connecting with us, they can connect with us via LinkedIn or send us an email at info. So the email address is info@hsclouds, the humanityservingclouds.org, or softgalaxy dot, like a full stop, hsclouds@gmail.com. Okay, so let's carry on. So by taking this course and the associated courses, so what one can expect as a career objective. So this particular slide not only highlights the course objectives, but also includes the type of careers you can think of furthering your learning towards. So in this particular course, our focus is on understanding the basic techniques, technologies, and working principles behind AI, ML, and DL for deep learning. You can be an AC technician, engineer using AI technologies for industrial and consumer applications. You can be an AI programmer. To become an AI programmer, it's highly recommended that or an AI engineer. You go join quality engineering colleges, universities, or private institutes where because it's a course like this can inspire you towards joining teams at universities and colleges in basically getting formal education and credentials which can help you, towards your key career objectives. So AI programmers using off-the-shelf, OTS stands for off-the-shelf tools for different industrial and consumer applications and project needs. So to inspire all of you, so what I have done, there are some video which I have selected, and if when you have this slide, the link is given to the video description below. It's encouraged to not only read but watch the entire videos, without skipping. That information contained in these video links will tell you that as of now, the AI technology, what AI technology has achieved, and it is significant achievement. So what is the significant achievement? Just to highlight, because people most of the time like games, so the fastest Rubik cube is done by an AI driven machine or AI driven setup. AI technology has defeated the world's very well known champion in chess, but the AI machine has beaten that world champion. The AI machine has beaten the Go champion. Go is a game, so the AI machine, the AI setup has beaten the Go champion. We use AI for self-driving cars, and we use humanoids, for using AI technology. So let's look into some of these videos. I think that is important to look into. So what we are going to do, so let's just go one of it here. So I have already made these videos, ready to play. So here you can, it's a 0.38 seconds Rubik cubes solver, but done by this particular setup. You can see here. So see, so that's how much time this machine has taken in solving the Rubik's cube. So let's look into this again. So again, as you can see, it's unsolved. Okay, so and the individual counts, and here you go, it's solved. So that's amazing. So please look into this video in its entirety and to get the rest of the details. Let's go to the next. So here is Kasparov. I think his full name is Garry Kasparov, and here's a Deep Blue is the name. The company who is using the AI technology, and this is the individual who is going to give the machine. This is the machine you can see here. It will give this machine an input, and based on the information the machine will provide, he is going to make the moves, while playing the chess game. So you can look into this. So as you can see here, his age now and at that time. So entering the sixth game, the score was tied at 2.5 each. So they're describing the entire story, but eventually the thing. So this is the scene you need to see, that he couldn't believe that how the machine is working, what the next move he should do, but because of this kind of, I'll say, pressurized situation, he just left the game, and that's exactly is basically, he got defeated, because he doesn't know that how he should play out this particular game. So, like with this machine, yeah, I mean by that, yeah. So let's go to the next one. So it's a Google's AI AlphaGo is beating humanity at its own games. So let's look into this. What it means by that? In a game of checkers, we have that many zeros as possibilities. In a game of chess, we have that many zeros, more zeros. And in a game of Go, the possibility of moves are so many. So it means that the Go is one of the most complex games to play. Okay, so while playing this game with Qi Jai, the world champion from China, so he played with the AI, and that's it. So after the defeat, he basically surrendered. So here's when he surrendered basically to this. So he's basically giving the AI machine as a computer. You can see here he's giving input to the algorithm that what moves are there, and based off the inputs to the machine advises the individual that what should be the next move, and he's basically surrendering and accepting his defeat to this particular game, AlphaGo. So here you go. Here's self-driving cars, as you can see. And they are, I shouldn't say as of now they are common, but there's a growing trend, especially on the US side, on using these self-driving cars. As you can see, the customer has placed the order. Here's the customer. After the vehicle comes in, he receives the order, and here you go. The vehicle, go back to the next destination or wherever the next place is. And similarly, so as you can see here, it's coming to the next client side. So self-driving cars has many applications relating to which is basically an AI-driven technology. There are drone technologies, which basically is the same. They pick up the order from the source and deliver it to the destination customer site. So here you go. Here's a humanoid. You can see Boston Scientific, products, very popular. And see the human working up here on the with the construction work going on, so he needs some help, and this particular robot is going to help and see that how it's going to help. There you go. So he needs a toolbox, so the bot is setting up his track. So see, this jumping around, that balancing, that's amazing. That's the work of many engineers, project managers. And here you go. So you have the toolbox with the balancing, and here it's delivered. Now he's going to come back. Obviously, it's he jumps and see the last jump. Amazing, amazing. There you go. So one of the last one is this is the MIT OCW courseware, AI 101, very well video. The link is given in the reference section of the slides, and I really encourage the attendees to see this particular YouTube video in its entirety without skipping. And the reason of me having the video stopped here is just to in brief tell that when it comes to machine learning, we are basically doing classifications. In this particular case, you can see, if we will think these as grains, okay, of different colors. So the black colors are green, and let's say these are brown. These grains are separated, and that's what machine learning can do. It does the classification, clustering, and regression in order to achieve the desired objectives. Okay, so let's move on. So in this particular course, here's how the distribution of marks will look like. So 10% will be the assignments, 5% before the midterm, and 5% before the final. The lab work which we will assign will be part of the assignments. Okay, and you will be tested on the given lab work as these marks, which is 20%. It will be an 1 hour exam before the midterm and before the final. So you will have a 1 hour exam. So 10% of an exam will be given to you before the midterm, and the rest of the 10% will be given to you before the final. And after the lab work exam, which will be directly relating to the assignments and the labs given to you, you will be given, let's say, half an hour, 1 hour break before the midterm will be handed over, which is a 1 hour exam, and the final will be handed over in the final day, in the day of the final, which will be hour and a half exam. There will be, we'll try to do, that's our intention, to have 4 industrial tours using AI, ML, DL technologies, either in the manufacturing, robotics, or different systems where the technology is employed, in order to give all the attendees a kind of a industrial, practical, hands-on, kind of an experience that how these technologies are utilized in the industry. Okay, let's carry on. Yeah, so this is a very good kind of a tree. Tree is a technical term we use in education. So any technology, in this case, let's say AI, is basically comprises of many other technologies. Machine learning is a sub technology, is a sub-discipline, is a subcategory which comes under AI, artificial intelligence. So that's, as you can see, how do you understand that. So ML is basically AI. That's what I'm trying to convey it here. And there are 3 types of learning when it comes to machine. There are 3 types of learning. One is supervised, as we just saw in the videos, that someone is assisting the machine to complete the task. So that type of learning is called supervised learning. And unsupervised learning is where the machine learns itself and perform the decisions. So that's an unsupervised learning. And the reinforced learning is kind of a supervised learning, but with a very, with the difference which we'll describe, here. The difference among the reinforced learning and supervised learning is this, that in reinforced learning, it doesn't need labeling input-output pairs, and we'll learn about it, what it means by labeling an input and output pairs. Over here is basically based on the data input. We label the data, and how we label the data we will learn. That's what it means here, labeling the input or the output pairs. In supervised learning we do that, but in reinforced learning that's not what we do. Instead, the focus is on finding a balance between exploration and exploitation of the current knowledge, and we will see how what this means. Anyone interested, finding out the details, you can click on this link and go read more about reinforced learning. But in simple words, it's basically it uses a technology called gradient descent, mathematical concept relating to this particular sentence. Just pictorially representing what we just discussed on this particular slide. So supervised learning, and something like similar. Okay, so the sources of all this information is given right below. So here's another very good slide which help you understand how these three keywords are connected. We already discussed AI, ML comes under AI, and the deep learning is basically is a subset of machine learning. So this is a simplest kind of a tree that how these three technologies are connected together. So there are many disciplines under AI. Machine learning is one of the disciplines. There are many disciplines under machine learning, and under one of the discipline is deep learning. Okay, so since we are discussing this, I think this is a very, as you can see here, artificial intelligence and machine learning is there, and under reinforced learning, so this block is basically reinforced learning under which the deep learning comes. This tree is not complete by any means, because why I'm saying that, because I'm not an AI researcher. When we talk about research, there are so many years of research under a particular discipline, in this case AI, and I just took these images that were the links. If you click on the image, you will go to that link and you will find the relevant details. But I'm just based on my industrial experience and university learning, the particular area of research keep on growing. But anyhow, so the popular ones are shown here in this particular tree. So artificial intelligence, as you can see, problem solving, machine learning, knowledge representation, planning, natural NLP, say is a shortcut, what they say, NLP, natural language processing, computer vision, and under computer vision there's so many others. But since we are just focusing on this AI, ML, and DL, so as you can see, there's supervised learning, unsupervised learning, and reinforced learning, and within that there's so many other areas, and deep learning is one of the area under reinforced learning, where they use primarily gradient descent as one of the techniques in order to achieve DL objectives. And I really like this picture as well. As you can see, rather than seeing it like this, it gives out artificial intelligence, the definition or the description, what it means, the machine learning, and the description, what it means, and the deep learning, and its description. Okay, let's carry on to the next slide. And these images are, as you can see, are the same. Okay, so basically in AI, so these are, you can think these as a processes, that how we used AI in solving problems, or making or bringing efficiency in problem solving. Okay, so basically we set up our goal, that what is our goal, and based on that goal we train the data. So what it means, that it means the data is already there. We already have the data. Okay, based on that data, we set up our goal. Okay, and using AI, then we train the system on that data. Like in the game of chess or the game of Go, the data is there. What is the data? Because the chessboard is there or the board is there, the opponent is there, okay, and the data will be coming in the form of what the opponent moves are. So that's what the data, and the goal is to defeat the opponent. So the AI will train based on that moves, which will the opponent do, okay, and then based on that moves, the model will perform its function towards this goal, okay, and then it will, the fourth is, it will, the model performs accuracy check. Okay, so there will be accuracy check that how the model is performing, whether the model is performing better or worse, and that based on that accuracy check, the next or the subsequent decisions will be taken. I think I already mentioned you in the slide that please look into this MIT OCW YouTube video in its entirety, and that will really help you, give you kind of a very good intro, kind of a deep introduction. I'll say the deep introduction, a detailed introduction on what we are discussing right here. Okay, let's carry on to the, and in this particular course we will cover all these processes, what it takes in order to achieve our desired objectives using AI, ML, DL technologies. Okay, so basically, just pictorially, that you have input. What is machine learning? You have input, and the algorithm will extract features from that input, and it performs classification as we discussed before. The reason of showing you these pictures, because that's exactly what we're going to learn, that how these dots are connected, what we mean by a dot in here. So in simple words, in the subsequent slide we'll discuss that, and as an output then we'll make a decision whether the input is a car or not a car. Similarly here in deep learning, we do the same, feature extraction, classification, and make a decision as the output. That's how your deep neural network can be. It can be multi-layer network, and the reason behind those multiple layers is to achieve accuracy, not only to achieve accuracy but also to reduce time in decision making, and that's what to giving that as output. And we will learn the basics behind that, that how it works. And this is kind of another pictorially representing the deep neural network, a diagram that we have the input layer and the middle layers, which are hidden layers primarily, because these layers are not visible. The user is just going to see what the inputs are given and what the output is coming out. Okay. Yeah. So during this course, we are going to work with these tools in learning, not in detail, but we are going to use these tools, which are very popular in the AI, ML, and DL community. Keras, TensorFlow, Caffe are the most commonly used, but we will see based on our what problem we are trying to solve, we may go ahead and use other tools as well. So as you can see, these are best AI development tools and frameworks known to AI community as of now. So generative AI is another popular kind of area of research where they used AI technology uh, for for generating different, I'll say, outputs. So, for example, one can generate art, which is AI driven. You can generate images, videos, text, 3D, animations, speech, or a code, all driven by AI technologies, and that's why it's called generative AI. And as you can see, there's so many areas within this particular area of research, but that's not be the topic we'll be focusing on. We'll be more focusing on learning the basics of AI and how we can use the AI technologies for practical industrial and consumer application use. And these are the 9 best free AI platforms known as of making of this video, and we will get a brief overview on Google AI, Microsoft Azure, and OpenAI platforms, and we will see. Maybe we have already discussed that we're going to look into TensorFlow, but again we can look into Amazon Web Services as well, or NVIDIA or others if required and time persists. Okay, let's carry on. So this is the evolution of, you can say this artificial AI analytics. So the business intelligence, big data, predictive analysis, real time, and deep learning. So what basically you can extract from this particular graph is that the use of AI is growing exponentially. Okay, so that's what you can extract out of this graph. Essentials were 2016 to 17, early adapters, leadership. As the time is going on, the different use cases of AI is growing exponentially and using different technologies within AI. And there's another, I really like this graph again, just to show that how the AI technology is, getting mature, going to its maturity, and that's, particular graph and associated with that. As you can see, this technology maturity, how, as you can see, there's so many technologies, going on, directly relating to AI. In simple words, when you see this graph, as I said right in the beginning, it's going to affect human societies globally in almost all industrial or consumer segments, and it's a big debate to regularize the development and use of AI to make sure that it's it will not be utilized for any negative purposes. So that's another, I'll say, a very good block diagram which shows the artificial intelligence segments comprising the ecosystem. As you can see, the first step is basically preparing the data, then sensing and thinking that what we can do with that particular data and what are the real-time inputs. Then we act and learn, and the key use cases are described in this particular kind of a diagram. There's another very good graph which shows the technology maturity and market segments and the percentile use. So again, without going into the details, please pay attention. Any questions you have, please write down in your notebook, and we can discuss in our Q&A session. And the source, if you click on the image, you will go to the source and can read out the details associated with this particular graph. So that is I'm just going to just give me a minute. So here's a short history of artificial intelligence and neural networks. So it goes back as BC, 350 BC. Aristotle was the first to lay out the foundation of this field by defining a set of precise laws governing the rational part of the mind and creating a formal system which in principle allow the automatic generation of conclusion from initial premises. Here's a web link. Please go out and read out the associated details, but I think this is all of this particular timeline. The most important one is I'll say even though you can trace back to Aristotle, but I think the most important one was George Boole in 1847 work on Boolean logic, followed by Gottlob Frege. I really excuse if I'm not pronouncing it right. In 1847, again laying out kind of a concrete foundation relating to Boolean logic. So we'll discuss in this particular course the details relating to that, but since this is just an introduction, we'll just keep carry on. The idea behind showing you this without going into the details is that when we talk about artificial intelligence, it can go back as Aristotle times, 384 to 322 BC. And this is the modern machines. The modern machines we work with is kind of attributed to the work of Alan Turing, which we know as the Turing machine. He designed in 3637. That is kind of an original kind of a look of that machine. It basically had a tape, on both sides, and the tape gets divided into segments, and every segment has an information written to it, and we'll read about it briefly, that how that goes. So as you can see here, a physical Turing machine model, a true Turing machine would have unlimited tape on both sides. However, physical models can only have a finite amount of tape. Okay, so but the model, because he was a mathematician, so mathematicians love to work with infinities. A Turing machine is a mathematical model of computation describing an abstract machine that manipulates symbols on a strip of tape according to the table of rules. And we will learn about what the table of rules were, during this particular course, just to have a complete understanding of not only the origins of AI, the modern machines, and the further evolution into ML and DL. Despite the model's simplicity, it is capable of implementing any computer algorithm. So think how how powerful kind of this particular machine was envisioned as. And these are the pioneers of artificial intelligence in the 50s. These are the pictures. If you click on the picture, you will go to the link from where the source is. But these individuals, 7 of them, were the pioneers in the field of artificial intelligence. Let's carry on. So Turing machine, he developed in 36, got a use case in World War II, which basically went from 39 to 45, and there was a need to decode the German messages. So deciphering solution was a need. So Bombay was the machine developed by Turing in that particular time. So let's read this particular slide. So this is the Germans were using this machine to send messages. Okay, and this machine was known as Enigma, as you can see here, and this is one of the kind of a series of rotors utilized in this particular machine. Although Polish mathematicians have worked out how to read Enigma messages, which is a enciphering machine, and had shared this information with British, the Germans increased its security at the outbreak of war by changing the cipher system daily. So even though the deciphering solution was there, but since the Germans, obviously they must have came to know that they are deciphering their messages based on the Polish mathematician solution. So what they were doing, they were changing the cipher system on a daily basis. So daily there is a new coding scheme to send the message, and this made the task of understanding the code even more difficult, like very difficult. So there is not one standard code they were using. They were using and they were changing the code on a daily basis. So that's where the Alan Turing came in, and Turing played a key role in this, inventing along with fellow code breakers Gordon Welchman a machine known as BOM. So that's the machine they built. The device helped to significantly reduce the work of the code breakers. From mid 1940, German Air Force signals were being read at Bletchley, and the intelligence gained from them was helped the war efforts. So here is one of the connections, as you can see here, and in this Bombay machine. So what it's doing, it's connecting S with O and A with G, and in relation to deciphering the message. Okay? There's also a very good movie. If you go into Netflix, I forgot the name of the movie, but if you just simply search as Netflix Alan Turing, you will find the title of that particular movie, which basically covers all that particular World War II like scenario, that and how Alan Turing and his team worked to make it work. Okay, let's carry on. So in this particular slide, the work done by Alan Turing was further worked on, and one of the most popular publication by McLauch and Pitts, and that these are their picture, is basically on presenting the first mathematical model of a neural network. So that's what happened in 43. You can go and read the details, but in simplicity, they proposed neuron as a I think this is the snippet from the original publication. If you click on it, you will go into the details. In the course, we will discuss that the progression of Alan Turing's work, followed by McLeod and Pitts, and discuss this. But over here, for the introduction, is simplicity. Is basically that's the simplest model they presented. That there are multiple inputs, and based on the gain, there will be an output either 0 or 1. Okay, so that's kind of a mathematical model presented for a neuron, which is a basic kind of a processing structure in biological organisms, including human brain. So the new keywords, so these are the new keywords introduced in the 50s, called Turing test, machine learning, genetic algorithms, and reinforced learning. Again, this is a picture of all the pioneers, and that publication basically introduced all those three keywords, and that was also a publication of Alan Turing. Please click on the link and you will go to the source and you can read through it, and we will discuss briefly during this course as well. So the neural model presented by McLeod and Pitts were further kind of enhanced, and the work done by Frank Rosenblatt. He in '62 he defined the term called perceptron, and that's the model of the perceptron, similarly to the previous mathematical model, but it's more generic because the model presented before were more like binary, but that's not the case here for perceptron. It looks same, that you have inputs and there are weights associated with the inputs, so it's basically the key difference, and there's a bias, and based on that you make your output decision, that what the output can be. But in simple, if you need to see this in simplicity, that's what the output can be. If the sum of inputs multiplied by their weights is greater than 0, then it will be 1 as an output, otherwise it's 0. Yeah, we will discuss the detail as we go and progress in this particular course. So research is one thing, but what are the because of the worldly realities in the mid-60s, here are some of the keywords. Please read the entire text in its entirety, but I'm just going to that even though the research was quite attractive, but the result was the total, but there was because of no scientific progress, and secondly because no concrete application. So these two factors, because research needs funding, and these are the two most important factors in any research area, that they want to look into our progress and they want to have some concrete application relating to a particular research. But AI in the 60s, in the mid-60s, because of lacking in these two areas, and by the demonstration by Minsky and Pepper that the perceptron was unable to learn simple function like an exclusive OR. Because of all these, the American funding and the UK funding was stopped. Irrespective of that stop of funding in the mid-60s or in the late 60s, the back propagation algorithm was proposed, and that is the main propagation is the main algorithm we use in our AI applications nowadays in year 2023. So see that, but that's I'll call that's all about passion. That I kept on working even with the stop of research funding. The mid 80s were the theater of a comeback of connectionists model, thanks to the rediscovery of the back propagation algorithm and its successful application to many machine learning problems. So it came back in the 80s because of continued efforts and showing the applications relating to that how AI can apply into different industrial segments. So let's carry on. So here's the biological neuron, how it looks like graphically in a very simplified form. It had dendrites, which are inputs, soma, the processor. You can think of this as you can see, processes the information. Axon is basically the transfer, the output of a neuron, which synapse, which connects to other neurons. So inputs, the processing element, and the transmitting element, and this is the connecting element, synapse, to other neurons in its simplest form. Okay, so that's what we are talking when we talk about neurons. And so what happens is primarily this is just an example that when we laugh, how we laugh. So there is not first of all, there is not one type of neuron. Okay, that's very important to understand. There are neurons. Some of the neurons activates when the visual is funny. Some of the neurons activate when the speech is funny, and some can activate when the text is funny, along some others. And the combination of all that, if it goes above a particular threshold, only then the laughing neurons activates when you laugh. So that's kind of in its simplest example. And here's a detailed kind of a look of and the associated parts relating to a neuron. Okay, that's not a part of this particular course. So go into the details. It will be more, this is enough for us to understand, and that's what we'll be focusing on. Let's carry on. And that's how a neuron, the green color, all of that is basically electrical activity, and and they used fluorescence microscope to detect that activity, that how active neurons are. And this particular picture shows different kind of neurons: unipolar neurons, bipolar, multipolar, pseudo unipolar neurons. Okay, so this picture really gives a cool look what a neuron is and the associated details to that. And here are the actual picture, biological look of neurons. Anyone interested, please click on this link, and because that's exactly from where I took all those pictures. And these are the microscopic looks of different neurons and how they look in reality in a biological organism, including humans. So here are the preliminary course requirements. High school, college, decent knowledge of mathematics and programming, and a decent understanding and knowledge of microcontrollers, microprocessors, DSPs, and FPGAs. Very important to have this as a prerequisite before you can, we think, perform good in learning this particular course. There are the references, and we'll be looking forward you joining us in our subsequent lectures. Thank you.